Hello everyone, today's presentation is going to be on spec-driven development with GitHub SpecKit. The idea of this presentation is to give a general high-level overview of what GitHub SpecKit can provide, give some information on spec-driven development, and at the end, give a live demo to demonstrate how it works on a single feature. Spec-driven development is here to address a single problem, and that's the idea of using prompts with AI and agents. For example, we're going to think about the idea of building out a URL shortener. If we have this idea, we might first write a really big prompt and have the agent write the feature, implement it, and do everything. It works, it runs, it's perfect for maybe 10 minutes. 2 weeks later, we have someone completely different. We'll kind of ask and look into the URL shortener of the application, thinking about specific questions like why is the storage a global mutable object? Or why is the code 8 characters, not 6 characters? From this point, after the fact, nobody has any idea. There's no files or artifacts or place that we can go back to. There's only a archived chat log that we can kind of look and see at the higher level what was asked in the prompt, but we don't have any idea on the specific implementations. In this problem, we already see that if we ask 2 different people to prompt the same agent for the same feature, we're going to have 2 completely different implementations because they're both written with unwritten assumptions that are baked into it. Here we can see the problem is the AI or the model or the prompts. It's just that nothing was decided before we had the code. So nothing can be checked after it. What spec-driven development is a way that we can solve this problem that we have. In a sense, more specifically, it's a discipline that separates why, what, how, and order into distinct written artifacts or files or places of references. These are all produced before any implementation code exists and answers these 4 questions. Why? This is answered by the Constitution. This is the non-negotiable principles that we have when we create these different implementations. The what, we're creating the spec. This is the requirements and user stories in testable language. The how, this is the plan, the technical design gated against the Constitution. And finally, we have order. This is done via the tasks, a dependency order checklist. The implementation just executes. Let's get into the commands and mechanics that are within SpecKit. Here we have the whole pipeline left to right. We'll start with specify init, go next to the speckit-constitution, speckit-specify, speckit-plan, speckit-tasks, and finalize with speckit-implement. The first command, speckit-init, that's what we start for the entire setup. It's going to scaffold the Constitution template. It's going to create all the different placeholders within the Constitution. It's going to generate all the skills. And the skills are the commands that we're going to use after specify init. But this one doesn't have any content whatsoever. This is just a pure setup. This is what we use in the very beginning of our project. If you look at each of those commands, they are a specific skill. It's going to have its own skill markdown file. The biggest thing we want to understand is the agents are following this playbook. They're not a program in itself. Within this pipeline, though, there is one specific command, the speckit-plan, that will actually go backwards. So all of these commands are going from left to right, but the speckit-plan will go back to the Constitution and it will check it and see whether or not it passes or fails. Thinking about this demo that we have, the URL shortener example, this whole sequence of going from left to right, Constitution through a actual working curl call will run about 35 minutes start to finish. This is the first command that is run. It doesn't read anything. It has no prior artifact or file. This is the very first step. And then what it writes is just the pure scaffolding. It creates a .specify folder structure and it generates all the relevant skill files. It's going to generate the memory. It also drops a constitutional template, and this is going to be just full of different placeholders, tokens. There's no principles written yet. The biggest thing we have to remember is we're running this in the very, very beginning only once. So there's zero feature content. There's no spec. There's no plan. There's no code. It's pure scaffolding. And this exists so that every other command in this pipeline assumes this folder structure, and these skills are already in place. The next command that we have in the pipeline is a speckit-constitution. This one is the first command that writes something real. It creates the constitution markdown from the constitution template that we had generated before in the specify init. And here we're thinking about the idea of creating principles. These principles are things that throughout the different later commands like spec, plan, task, and implement, it's going to read this file. It's going to make sure that it follows those principles and constraints so that every design gets checked against those. It's not going to read anything. So here in the very top, we're going to see an excerpt from the Constitution. We have the first principle, simplicity and legibility, and we have this principle, the fourth principle, traceability from spec to code. The biggest thing we want to understand is these are must and must not ideas that we want to make sure we're always considering and thinking about when we're going through the rest of this pipeline. In the Constitution, we're going to create principles, and that's an important distinction that we want to make between a principle and implementation choice. The implementation choices are what we're going to define after we have defined the Constitution. A principle is a non-negotiable project-wide rule that constrains every later decision. This isn't a requirement. It doesn't say what to build. It says what's off limits or required, no matter what gets built. This is the source of truth, so every other implementation will look back at this principle. The implementation choice here is the features, the things we want to build out. Those are the specific technical decisions made later that must satisfy the principle. But this isn't a principle. That's a very important distinction that we want to continue to consider and think about. The rule of thumb, to just make it very simple, is if the same rule could hold across 10 totally different features, then this would be a principle. If it's a specific thing that's picked for this feature, then this would be an implementation choice. Here, if we look at the demo, we are going to have a contrast between the principle and implementation choice. Let's first look at the Constitution. At the first principle defined, it says must be readable in a single pass by someone who has never seen SpecKit before. The idea is use fewer files and fewer moving parts. This is the principle. Later, once we have the plan, we go back to the Constitution check looking at that principle, simplicity and legibility. We pass it because the implementation choice is using 4 small files total, plain express routing, and then there's no framework magic. The implementation choice here will satisfy the principle with a pass. Notice the principle never says explicitly we should use 4 files when you use express. It only states fewer and plainer. The plan is where that one specific file count and the one name framework is decided on. Here we have the speckit-specify. This command will read from the Constitution Markdown. It's going to make sure that from our feature implementation, it's going to fit into those principles, non-negotiables that we had defined within the Constitution Markdown. This command will also create the spec markdown. Here we have an example of this markdown at the top. It's going to create prioritized user stories, each with the values of P1, P2, P3, each with their own acceptance scenarios and independent test. The idea of this command and the spec markdown is it's going to turn that one-line feature idea that we kind of push into this command into this markdown that can be checkable, prioritized before we do any design or implementation or anything like that, just for review. After the speckit-specify, we next go into the speckit-plan. This is the one that reads both the spec markdown and the Constitution markdown that we had before. We are going to create the plan markdown, also generating the research markdown, data model markdown, and contracts folder. Here, we're going to do this Constitution check. Each principle, we're going to see whether or not the technical idea and plan will pass or fail the principles that we defined before. At the top, for this example, we were checking against simplicity and legibility, make sure it passes. If it passes, how does the plan pass that? We have the 4 small files total, plain express routing, no framework magic or generated boilerplate. The second one, we're looking at minimal dependencies. That was our principle from the Constitution Markdown. How did that pass? We defined that through the technical implementation of using Express. This is the only runtime dependency. There's no test framework, no build step, no TypeScript. So from here, we can check every principle, ensure that it passes or fails against the actual design once before we do research and once after, before we move on to those tasks. The fifth command that we have here is the speckit-tasks. This will read the plan markdown and the spec markdown, and it will write out the task markdown. This markdown file is a phase dependency order checklist. So at the very top, we have this example of one. We have the phase 1 setup, and we have a list of different ways that we're going to go off on the checklist. Like the first one, create this directory. Second one, initialize the package JSON. If you look at those boxes as well, they're already checked in this excerpt. And that's what we want to see when we're in this completed run. The idea of this file is we have this plan that is something that an agent or a human will execute one checkbox at a time, and it's grouped by a user story. And the purpose of this is a big difference between between the idea of we design something and here is the exact order in which it was built in. The sixth and final command we have is speckit-implement. It reads the task markdown and everything else upstream by reference. We look at all the other markdowns like the plan, the spec, and constitution. And from here, we'll write out and produce the actual source code implementation. This is the only command in this pipeline that will produce that working software. Before we had run the tasks. From here, we're going to go through that markdown and those tasks, and we're going to mark as each one completes through the implementation. We want to do this just to showcase that nothing has been improvised. We're going through this entire pipeline. So every command and markdown before had already decided what we wanted to build, and we're showcasing the purpose, the reason, and also what we're doing through this workflow. The big concept of using SpecKit, using this workflow, is understanding the purpose of traceability. We have this core traceability spine that we're using as we're going through each individual command, each step, that we can go backwards and see the reason and rationale, the task, and how we came to this implementation. From the very beginning, when we have the spec markdown, at this example, we can see there's just one very high-level, simple English rule. Here we're just saying, the system must allow a user to add a new task with a non-empty description. There's no complicated technical jargon. There's nothing that we're saying we have to do this or that yet. When we go in creating the tasks, this is when we have an actual build step and we connect it back to the spec markdown. Here we're saying we need to create a post endpoint, reject 400 when the description is empty or missing. We have this defined and we're connecting it back to the spec markdown. When we look into the generated code in that implementation, it's going to have that same task or same spec defined above the code that enforces it. From here, we can keep going backwards and we can trace at each point where we had defined it, where we had created the tasks, where is the implementation. So this all had been generated from the very beginning from that one sentence requirement. Here is a comparison between spec-driven development and vibe coding. If we think about how fast we can just implement and get our feature to actual code, the vibe coding is the fastest. We're just putting a prompt into agent. Through this process, it is slower, but the benefits, as we said before, is we're able to see the logic, the assumptions. We go through this research process, we create those tasks. So we are creating the artifacts files, which come first. This goes into the next point. We have traceability. The prompt is all that we're given into the vibe coding. There's no requirements, there's no information. Spec-driven development will carry the features through this identifier. We can see clearly that process and flow throughout this process. Also, when we have vibe coding on a team, it's going to break very fast. The reason why is every new session will reinvent new assumptions. It's hard to keep track of every individual member of the team's implementation. Why did they implement? What happened behind the scenes? Spec-driven development will have one shared constitution. Those are the principles. And the specs are the implementations, those sources of truth. Revisability, we have to try and hope that every time we do create the prompt, it will have the same way it will implement or fix those implementations. If we want to have any revisability on spec-driven development, we can run through the original constitution, those principles, amend them. From there, we can just rerun the plan. It will go back to the constitution and just recreate, redo the planning, redo the task, redo implementations. If we're thinking, though, between the two, since vibe coding is incredibly fast, we can just create spikes, we can just do research. We're not really caring about full-blown applications. We just want to create very, very simple scripts that we want to use. So vibe coding still is better than spec-driven development. Spec-driven development benefits more on these long-lived features. When we have multiple people, it's not just us as a single user, and we're doing multi-session work. We have some additional commands that we can run. I had covered that pipeline. Those are the absolute necessary commands that we would run in SpecKit, but these are some additional ones that might help throughout this pipeline. The first one is speckit clarify. Asks up to 5 targeted questions. Answers go straight into the spec markdown. It's very important to understand the spec markdown is in the very beginning. It's the first part of going through that pipeline of figuring out how we want to implement a feature. We might not be 100% sure on even how to word the higher level. So this is a nice command to help go through questions and answers that we can add in the very first step. Next one is SpecKit checklist. This one is just a way that we can check the spec's wording for unquantified terms before they get risky assumptions. Again, this is the very beginning. We start with the spec markdown, go into the spec plan, then we go into spec tasks. A wrong wording in the very beginning can eventually cause issues down the road, even before it becomes to the implementation. So this might be a good one just to double check, make sure everything is fine. We have SpecKit analyze. This one will just check between all of those documents right before maybe we do the implement, between the spec, plan, tasks, and the constitution. We're just going to read and make sure that there is no issue between all of those documents that have been generated. We have SpecKit converge. This one will compare the spec, plan, and tasks against the actual code. It will append a task if it finds some drift. The last one, we have SpecKit task issues. This way we can export the task markdown into track issues for teams that live in an issue tracker. If we looked at the task markdown, it already is created as a checklist as a way that could be used in Jira. Again, this is kind of a nice way that we can just export those files and easily just put them into our issue tracker. That's it for this presentation. Here's some resources and next step. They can be found inside the description. There's another repo that I have, the SpecKit demo. This is a full-blown single feature, one person. You can see the difference between a vibe-coded application versus spec-driven application side by side. It might help, as well as a ton of documentation. We also have the SpecKit complex demo. This is another demo under the assumption that there's a team, 3 contributors, there are multiple branches, there is a mid-project constitution amendment, 2 real merge conflicts. This might be a good point of reference if you want to see how SpecKit can be used on a team. And lastly, I'm going to go over in another video, my next video, over the Facilitation markdown. This is going to be a live run of show. We're going to write out those commands. We're going to demo the pipeline that I had written before just to see what this would like in real time.